Okay.
Molecule group atom.
So atom is consist of one unsur. You
Yes.
said just now, right? Okay.
Yeah.
One element. As far as
One
you know, how
element.
many types of elements that we have? Kat mana kita nak refer to? If you want to know the symbol
Jadual.
of element.
Jadual berkali.
Periodic table.
Periodic table.
So we know that inside a periodic table we have elements like contohnya ni apa yang kita panggil elemen yang duduk di hujung sekali of our periodic table.
Hujung sekali kanan kiri.
What we call them?
Noble gas.
Table.
Noble
Noble gases. Right.
Noble
Contoh
gas.
example of noble gases.
Helium, xenon, krypton, radon, neon.
Ni semua without
Noble gas tu gas hadi
the periodic table kan? Semua boleh ingat kan? Okay.
Ya.
What is the significant criteria that you can
Dia
describe
hujung
about
sekali
noble
kat
gases?
table tu.
Stable.
Tapi dalam Melayu dia gas hadi lah kan.
So the
Aku
word
tak
there is
sure lah.
that, right? Okay. Alhamdulillah. So that's
Banyak
the basic
yang
things
banyak
about
function
chemistry
macam
lah.
helium.
Okay. So which means that molecule is consist of
Itu
apa?
kan xenon radon lah. Tak lah.
Two atom.
Two atoms.
Elemen.
Two atoms, two elements. Is it can be same element?
Yes.
Yes. Oxygen.
Helium gas. Helium satu je, dia bukan He2 kan. Macam oxygen gas, yes, it must be in form of O2. O. Lagi, like for example, kita ada
Hydrogen.
hydrogen gas, H2. That's correct. Okay. And then we know that molecule also can be in the form of compound. Can you give me an example of compound yang biasa?
H2O.
Yeah, yes, that's correct. H2O. Okay, H2O that contain hydrogen and oxygen. Siapa tadi bagi tahu? CO2. CO2 ada carbon and also oxygen. And we know that all of these elements are chemically bonded. Chemically bonded, that's why kita ada ionic bond and also covalent bond. Okay, and then what is ions pula? Apa yang you all tahu pasal ion? The negative ion is called
Anion.
anion. And the positively charged ion is what? Okay.
Cation.
So apa berlaku sebenarnya bila dia jadi positive ion dengan negative ion? Dia losing what? Lose what?
Electron.
Okay, alhamdulillah. So a very good background check up dekat situ. Okay, at least the basic things about chemistry masih lagi di dalam ingatan. Okay, I don't know why, but then I think you cuma boleh nampak separuh je my screen. Kita boleh nampak tak perkataan it cannot tu? Can you see that?
Sampai Ken je.
Nampak.
Nampak sikit.
I don't know why. Selalu okay. Alright, so inilah yang kita bincangkan tadi. Elements is the simplest type of substance. Element consists of one type of atom. So these are the things yang kita dah discuss tadi. Okay, and then molecules, it must be consist of two or more. Okay, two or more atoms that are chemically bound together. So that's the keyword for compound for molecule. It must be chemically bonded or bound. Okay, so that's why at the end of our syllabus later kita akan ada satu topik khas yang nak cerita pasal chemical bound. Okay, alright. So ini pula yang kita recall balik tadi. We know that an atom ni dia nampak macam spherical. It seems like it is a spherical identity, and in which at the center of an atom there will be a tiny region yang mana kat dalam ni, kat tengah-tengah ni kita ada this is the region where we call it as nucleus. Ingat lagi kata ni?
Ingat.
Okay. So inside the nucleus kita ada apa? Inside the nucleus we have
Proton and
neutron. And because of proton is positively charged subparticle, so that's why kita kata at the center of an atom, which is nucleus, is a positive region. Okay, and yang mana proton and also neutron will remain on the same position. Dia tak bergerak mana-mana dah. It will be the center of an atom. Okay, and then outside of atom, outside of nucleus, di luar nucleus tu dia sebenarnya an empty space. Dia tak ada pun sebenarnya macam physical boundaries macam ni yang membentuk bulatan tu, tak ada. There is no physical boundaries. Dia sebenarnya ruang kosong. But an atom, an electron for an atom, dia akan ada a very limited space. Dia akan ada space dia yang tersendiri, in which we are going to discuss about this, the location or the position of electron later dalam topik 5. Lebih banyaklah kita akan discuss pasal spherical shape of an atom. Cuma dekat sini as an introduction, we know that outside of nucleus, di luar kawasan nucleus, kita akan jumpa elektron. Okay, kita jumpa electrons. Okay, so disebabkan oleh di luar nukleus ni adalah empty space. Okay, so the mass of an atom sebenarnya rely on its nucleus. Yang tengah-tengah tu sebenarnya yang menentukan berat atom. Okay, sebab kat luar tu it is an empty space. Okay, so if you look at this diagram, nampak tak yang moving around adalah cuma electrons. Okay, so that's why when we are talking about chemical bond, if we have covalent bond, then there will be apa berlaku dekat elektron dalam dalam covalent bond?
Share.
Share elektron.
Sharing.
Okay, sharing of electron.
Berkongsi.
Berkongsi. Lepas tu dalam ionic there will be
Derma.
Lepaskan.
yes, there will be transference of electron. Maknanya dekat sini, in order to form bonds, the electron is the one that will be mobile. Yang bergerak-gerak ni cuma electrons. Partikel dekat dalam nukleus, proton and neutron tu dia memang duduk diam-diam dekat tengah-tengah tu. Okay, that's the purpose of I'm showing this diagram to you. Just to show you yang bergerak-gerak ni adalah cuma the electrons. But definitely within its region lah. Within its region. Okay, so ini pula you don't have to memorize this, don't worry, jangan risau. Tapi kita cuma kena tahu generally proton is positive, neutron is neutral and electron is negative. Itu sahaja. This is data from experiment lah. Okay, so clear. Okay, the next basic things that you should know in chemistry adalah when we refer to periodic table, then kita tahu akan ada dua jenis number, right? Okay, masa kat sekolah dulu you all panggil apa nombor yang ni? Yang nombor yang lebih besar tu. Yeah, okay, you call it as nucleon number, right? Okay, but in our textbook Silberberg ni, dia tak panggil nucleon so you are not going to see any word referring to nucleon number, tapi dia guna the word mass number. Tapi sebenarnya mass number ni sama sahaja dengan nucleon number. So mass number is representing total number of proton and also neutron. Okay, and the symbol here kita guna A. Okay, and then bawah tu what you call it? Masa SPM dulu.
Nombor proton.
Nombor proton, right? You
Proton
panggil
number.
proton number. Yeah, tapi most of the time our Silberberg is using atomic number to represent the proton number. Betul, okay je nak panggil proton number, tapi sebab our textbook is using atomic number. So kita akan stick to the term atomic number. So atomic number is always representing proton, number of proton, and in which we know that for a neutral element, the number of proton is equals to the number of
Neutron.
Elektron.
number apa?
Elektron.
Of
Elektron.
Proton sama dengan electron for a neutral element. Okay, alright. So and then Z tu is representing the atomic number lah. Okay, and then for the X ni, ini adalah the symbol of the element yang kita boleh dapat daripada periodic table. So for information, the arrangement of numbers ni kadang-kadang nombor yang mass number duduk atas, kadang-kadang mass number duduk bawah. Don't be confused. The most important things that you should know or you should remember, mass number is always larger than atomic number. So kita tahulah nombor yang lebih besar tu adalah nombor mass number. Okay, that representing the sum of proton campur dengan neutron. Okay, got it class?
Yes.
Okay, so now let's try with a very basic symbol kat sini. A basic symbol here, kita ada C12-6. So meaning that we know that this symbol, this C, is representing which element?
Carbon.
Carbon.
Okay. And then the mass number is,
12.
12.
and the atomic number is 6.
Six.
Okay. And then gambar kat sebelah tu dia bertunjuk dekat nucleus kita ada 6 protons, 6 neutrons, and automatically outside of the nucleus we have 6 electrons. Okay, alright. And then kat bawah tu pula O is representing what?
Oxygen.
Oxygen.
So we can see from the diagram sebelah tu we have 8 proton, 8 neutrons, and yes, okay Ahmad Faris. Okay, and then you have 8 electrons outside of the nucleus. Okay, so now let's test your your knowledge on the symbol of elements. Maybe you boleh Google lah, boleh Google periodic table. So could you please give me the symbol of gold?
Ferrum.
AU.
Aurum.
Aurum, right. And what is the mass number of aurum? Siapa ingat ni hebat ah.
Duit.
Cepat saya ni.
Ahmad Hussain ni buka periodic table ke? Buka buku tu?
196.
Berapa? 100 berapa?
196.
And 96. Sure, betul. Yang lain-lain
Hebat.
setuju?
That's on Google, yes.
That's on Google.
Yeah.
Ada yang refer to any predictable on the books?
79.
79.
79. That is what? So 79 ke 196 ni?
196 is atomic mass.
196 is atomic.
196
mass.
is atomic mass ke atomic number?
Atomic number.
Atomic number.
79.
Atomic number
Atomic
79.
number.
Ah,
Okay. Okay, sekali lagi. Atomic number berapa?
79.
79.
79.
79.
So which means that 196 is the
Mass.
mass number. Okay.
Mass number.
Because I don't remember the mass number here. Okay, so please double check. Okay. Alright. So ni satu lagi. Can you give me the symbol of tungsten? Tungsten. Boleh Google, Tungsten. Symbol of tungsten.
W.
W. Yes, very good. Okay. So that's the symbol of tungsten. And what is the mass number of tungsten?
74.
Itu mass number ke atomic number?
108.
Atomic number. 180.
180.
180. So you always need to remember the mass number is always bigger than atomic number. So maknanya atomic number dia adalah
73.
70.
74.
74.
74.
Atomic number is 74.
74.
apa ni?
74. Yes.
74.
Nanti sekejap lagi ada check predictable betul tak korang bagi ni. Okay. Alright.
Okay.
So yeah, definitely kita kena tahulah apa nama elemen tu. Sometimes ada elemen yang not very common, right? Jarang-jarang jumpa like tungsten ni, mungkin you kena kadang-kadang kena rajin tengok lah predictable. But don't worry, dalam silver book nanti dia punya predictable memang ada nama lah, name of elements. Okay, alright. So now one more. Can you give me the mass number of calcium?
CA. Yap.
40.
40.
And how about the
Twenty.
proton, the atomic number?
20. 20.
20. Okay. But what if we have calcium 2 plus? Okay, what if we have calcium 2 plus? If I ask you, how many neutron that we have for calcium 2 plus?
20. 20.
20.
Tapi dia 2 plus? Charge dia 2 plus?
Elektron. More elektron.
Okay, tengok
Dia elektron je yang hilang.
Proton, neutron, elektron. So, tadi Meda tanya neutron. Neutron dia berapa tadi korang bagi tahu?
20.
20. So, proton number?
8. 20.
20 ke 18 ke
18.
20.
20.
20.
Okay. Betul Tadi ada dengar cakap 18. So 20 or 18.
20.
20.
Okay. And then how about the electron?
18.
18.
18.
Okay. Kalau untuk calcium,
20.
untuk calcium sahaja, we know that the number of electron will be equals to the number of proton, right? 20, kan?
Yes.
Because
Yes.
of now, the charge is positive and in fact it is positive 2, meaning that dia dah hilang how many electron?
2 electron.
2 electron.
So that's why the number of electrons will be 18. Okay. Alright. So itu sajalah untuk atomic symbol. Okay. Maybe we can do some practice. Okay, jap I would like to share with you. Kat mana tu? Dekat WhatsApp. Tak apalah, later I will share with you in the WhatsApp group. Nanti you all try jawab more exercise on the atomic symbol. Okay. Now let's move to this slide. Okay. So isotopes. What do you know about isotopes class?
Same
Have
proton.
same proton but different number of neutron.
Unsur sama
Different
tapi
number.
Apa yang sama? Apa yang sama? Satu benda.
Proton number.
Okay, first of all, you need to understand that we are talking about same element same element. Baru kita boleh categorizekan dia sebagai isotopes So it's a group of same element, okay? But these element have different what?
Neutron.
Different neutron number but
Same proton.
Same proton.
proton. Tengok definition dia. Isotopes are atoms of an element with the same number of protons. Okay, tepat. But a different number of neutrons. Okay, soalan ni dia sebenarnya definition. Okay, definition is actually quite popular in the quiz and also in the EOS. Okay, memang kita selalu tanya define ini, define itu. So soalan definition normally we give you 1 mark 1 mark. Okay, but unfortunately it's not that easy for you to get 1 marks because bila soalan definition normally you must give a complete definition. Contohnya isotope, bila soalan tanya define isotopes, so if you give answers like atoms of same element that have different number of neutron, macam tu je you buat, di mana you are missing same number of proton kan, tak tulis dekat jawapan kan, then unfortunately you are not going to get 1 mark. And dekat sini is either 1 or 0. Kalau tertinggal point, you terus dapat kosong, tak dapat separuh dah, tak ada. Okay, it's 1 or 0. So definition ni kena alert. Definition dia tengok ayat dia. And we always refer to Silverberg ataupun nanti bila you dapat workbook besok, nanti you boleh tengok dekat glossary dekat belakang tu, we already listed all the most important definition. So you boleh refer to that glossary okay. So now let me enlarge this. Okay. So we know that this is a symbol of, ada tulis pun kat bawah tu. It is what? Uranium. Okay. And then you can see both are uranium. Dua-dua uranium. Cuma beza antara mereka adalah
Mass number.
Mass number.
number. Ada lagi yang confused dengan proton number. Okay, nombor yang besar tu kita panggil dia sebagai mass number. Tengok proton number dia sama. Okay, proton number sama, maknanya number of proton sama, number of electron sama. Yang berbeza cuma number of neutron. Because the first uranium is 235 and the second uranium is 238. Okay, so let's do one practice on this. Okay, kita tengok ni. This is sample problem from your textbooks. Nanti you all dah dapat buku, nanti boleh tengok lah, dia ada banyak sample problem. Dia ada sample problem, dia ada following follow up problems, ada banyak yang you all boleh try. So in these questions we have 3 naturally occurring isotopes. Okay, we have silicon 28, silicon 29 and also silicon 30. Okay, so what I want you to do now is please list down the number of proton, neutron and also electron for all 3 isotopes. 29, silicon 30. So nak kira proton, neutron dan juga elektron, maknanya kita kena tahu apa?
Mass number.
Proton number.
Okay. Mass
Proton,
number ke
electron number,
atomic number? What's
Atom,
missing here?
Atomic
atomic
number.
number.
Atomic number.
So
We
kita
only
kena
have
tahu dia
electron.
punya
Electron.
atomic number. So what do you think? Silicon, what is its atomic number?
14.
14.
So barulah kita boleh cari how many proton and also neutron and electron. So for the first one, in fact for all, kita akan ada berapa proton?
14.
14.
Silicon 29, how many proton?
14.
14.
14.
Okay, and
14.
silicon 30 also
same.
14.
14.
So automatically because this is neutral atom kan? Neutral atom, maknanya elektron dia ada berapa?
14.
14.
All are 14. So yang berbeza cuma number of neutrons. So for silicon 28, how many neutron?
14.
14.
Plus minus 28 minus 14.
Silicon 29, berapa number of neutron?
15. And then
And last
16.
but not least, kita ada 16. So that is how we define slash pula. How we define the isotopes depending on its number of neutron. Okay, clear? Okay,
Yeah.
so I will share with you more exercise on this later in the WhatsApp group. Okay, all right. This one also, if you already download my lecture notes, then you can try to fill in this table as a practice. Okay, apa jawapan dia? Kita ada semuanya. Okay, what do you think? AS is actually a symbol of what?
Arsenic, madam.
Arsenic, okay. So arsenic. Lepas tu RB tu apa?
Rubidium.
Rubidium.
Rubidium, and bawah tu adalah
Chromium.
Okay, so nanti you later pun because my next target is actually this one. Okay. Alright, so before we are talking about this, kalau you all recall balik lah, macam mana nak kira mole?
Mass.
Formula dia.
Mass over molar mass.
Mass over molar mass. Okay. So in this case, we know that mass is very important. Mass is very important in our calculation because as simple as finding mole pun sebenarnya kita perlukan mass sebab mole ni sebenarnya is actually we convert mole from mass. Okay, sebab kita lebih senang deal with mole when it comes to atoms, molecules and also ions. Okay, kenapa dia lebih senang? Sebab we know that atoms, molecules and ions are extremely small, sangat kecil, cannot be seen by using bare eyes. So that's why we have something that is measurable for them. Okay, so to make it easier for us to do the calculation, so dalam chemistry ni kita ada our standard. Standard dia adalah apa-apa pun the mass of an atom is measured relative to the mass of an atomic standard, our standard. So our standard in chemistry is carbon 12 atom. Kita jadikan dia sebagai standard. Bila kita jadikan dia standard, maksudnya apa-apa pun kita akan compare dengan carbon 12. Okay, helium, is it heavier or lighter or maybe as heavy as carbon 12 atom? So kita compare. So the word relative here meaning that kita compare. Okay, and then because of atom is extremely small, so kita tak boleh guna kilogram. So kita tak boleh cakap macam oh I have 1 kilogram of magnesium. Tak boleh, tak sesuai sebab atom ni sangat kecil. Because when you have 1 kilogram of magnesium, you actually have a very large amount of magnesium sebenarnya. Okay, so to make it in par, so untuk atoms ni kita ada unit yang sesuai yang mana kita panggil dia sebagai atomic mass unit, and in short the short form is AMU. So maknanya starting from this ataupun mungkin dekat sekolah pun you dah tahu kan atomic mass unit is for an atom. Okay. So for the atomic mass unit, when we compare it with our standards, biasanya kita akan buat this type of calculation lah sebenarnya. Apa-apa pun bila kita nak compare dengan carbon 12 atom, yang mana carbon 12 atom dia punya mass is kita setkan mass dia memang tepat 12 AMU. Maknanya ni berat standard untuk carbon 12 kat mana-mana pun. In the whole world lah. Semuanya akan kata bila kita sebut carbon 12, then we know that the mass is always 12 AMU. Okay. So bila kita compare dengan carbon 12 atom, biasanya kita akan buat formula dia 1/12 darab dengan mass of one carbon 12 atom, maksudnya darab dengan 12 AMU, dan kita akan dapat nilai 1 AMU. So dekat sini nilai 1 AMU is actually very difficult for us to imagine. Berat ke ringan ke? Dia macam kalau kita bagi tahu, oh berat saya 50 kg, berat Adam 45 kg contoh. Okay, so kita tahulah berat dia 45 kg, oh dia kurus orangnya, because we can imagine the value, we can measure the value of kilogram. But when you're talking about 1 AMU ni kita tak boleh imagine. So to help us to imagine what is the value of 1 AMU, then you boleh tengok kat sini. 1 AMU is actually equivalent to this value. Nampak tak? Sekejap, besarkan. Okay, is equals to this value, 1.66 times 10 to the power of negative 27. So maknanya nilai 1 AMU tu sangat besar ke kecil?
Kecil.
Kecil.
Sangat
Kecil.
So kita tahulah, oh yes, atoms, molecules and ions are extremely small sebab 1 AMU dia bersama dengan 1.66 darab 10 kuasa negatif 27 kilogram. Clear class? Okay, itu just macam mana kita nak imagine the value of 1 AMU when we're talking about 1 AMU. Okay, so now, bila kita cerita pasal simbol tadi kan, A, Z, semua value tu, yang mana kita tahu the number yang selalu we always refer to in order to identify, kalau kita cerita pasal carbon, okay, carbon is 12. Maksudnya kita tahulah kalau dia punya mass number is 12, then we know that it belongs to carbon. Okay, it will give the identity to that element. So this mass number is very important, sangat penting, yang mana mass number ni always can represent salah satu dia adalah, we call it as average atomic mass. Okay, average atomic mass. Why we have this term? Kenapa kita ada terms average atomic mass? It is because of, then yang main tadi, kita ada isotopes. Kan, kita ada isotop. Contohnya carbon 12. You all tahu tak isotop apa lagi yang ada untuk carbon? Is there any other isotope for carbon? Ke carbon memang ada carbon 12 je?
Carbon 14.
Carbon 14.
Yes, carbon ni sebenarnya bukan ada carbon 12 sahaja. Dia ada carbon 13, ada carbon 14, ada carbon 15, and all of these are isotopes. And setiap isotop ni dia ada mass yang berbeza-beza. Kenapa ada mass yang berbeza-beza? Sebab dia kan ada different mass number. Carbon 12, makanya mass number dia 12. Dan berat dia adalah 12 AMU. But when it comes to carbon 13, then the mass is different sebab mass number dia 13 sekarang. So maknanya berat dia adalah 13 AMU. So kalau you all refer to predict table, hopefully you ada download ke ada Google predict table. Kalau you all tengok dalam predict table tu, value dia, bila tengok simbol carbon, value yang dia bagi bukannya value 12 tepat-tepat, tapi dia ada bagi 12.01. Nampak tak? Dia ada decimal numbers. Okay, ada decimal numbers. Lagi contohnya kalau you all tengok ni oksigen. Tak nak oksigen. Magnesium. Berapa mass number yang dia bagi?
31.
24 point?
305.
Ada decimal numbers lah kan, 31, sometimes it is recorded as 31, sometimes it's 305, something like that, tapi dia ada decimal numbers. Mana datangnya all these decimal numbers? It is because of value mass number ke atas ni sebenarnya datang from average atomic mass, and this average atomic mass comes after we consider all the isotopes, and cara kita kira adalah menggunakan formula ni, formula yang dalam biru ni. Okay, mass of various isotope darab dengan percentage abundance. So apa maksud percentage abundance? So let's have a look at this example. You all boleh tengok tak yang ni? Mungkin blur sikit lah kot. Lithium ni. Natural lithium. Can you see that?
Yes.
Okay, so tak apa, dia baca sekali. Okay, so naturally lithium ni dia bukan ada satu je tapi dia ada dua. Dia ada lithium 6 and also lithium 7. So by right at this point semua dah faham dah. We are talking about isotopes sekarang. Lithium 6 and lithium 7 isotopes. And yang mana when we are talking about percentage abundance, sebenarnya we are talking about which one is the most abundance. Yang mana yang lebih banyak. Okay, and then the percentage abundance is always scaled to 100%. Selalunya kita scale to 100%. So that's why bila kita totalkan percentage abundance untuk setiap satu isotop tu, you akan dapat equals to 100%. So dalam kes ni kita ada lithium 6, dia punya percentage abundance is 7.42%. Yang mana isotop yang lagi satu, lithium 7, the percentage abundance is 92.58%. Maknanya naturally antara dua ni yang mana satu lebih banyak, yang lebih mudah kita jumpa? It's more common. Is it lithium 6 or lithium 7?
Lithium 7.
Lithium 7. So itu maksud percentage abundance. Maksudnya dia punya percentage abundancy lebih tinggi. So maknanya kalau kita ada sample of lithium, mungkin kebanyakannya adalah lithium 7 dan sikit-sikit sahaja lithium 6. Okay, boleh faham tak percentage abundance?
Boleh.
Okay, so now sekarang kita nak kira average atomic mass. Okay, average atomic mass, bila kita mention the word average, kalau ikutkan mathematical skills, apa yang kita boleh buat adalah, you tengok kat sini ada individu, ini kita panggil sebagai isotopic mass. Isotopic mass maksudnya berat untuk individual isotopes. Berat untuk individual isotopes. Kalau ikut mathematical skill, nak cari average, apa kita boleh buat adalah kita ambil je lah 6.015 campur dengan 7.016, lepas tu bahagi 2. Dapatlah average kan? Okay, mathematically. And don't be surprised kalau dalam final exam ataupun dalam quiz ramai yang buat calculation macam ni. Bila soalan keluar, calculate the average atomic mass of magnesium. Kucing siapa tu? Okay, so kalau kita tengok dia ada 2, kita pun bahagi 2. Ada 3 isotop, bahagi 3. Yang mana is totally incorrect for isotope. So kenapa dia salah? Sebab remember the isotope ada percentage abundance. So that's why we need to use this formula to calculate the average atomic mass. So dalam kes ni, let's have a look at calculation kat bawah tu. 7.42%. So this is percentage abundance for lithium 6. So ini untuk lithium 6. Darab dengan isotopic mass untuk individual lithium 6. Yang mana mass dia bagi nampak tak? 6.015. Kadang-kadang mass given to you for the isotopic mass, decimal places dia boleh sampai 5. 6.0155555. Dia boleh jadi a very long decimal numbers. But in our calculation, you need to consider all decimal places. Kena masukkan semua. Kalau kita tak masukkan semua, jawapan kita, final answer kita will be inaccurate. Tak sama dengan dalam predictable. Okay? So you need to consider all the decimal places given to you. Nanti kita tengok contoh sekejap lagi. So in this case, 6.015, my advice is in your calculation, always write the unit. Kita tahu unit kita adalah AMU, right? When we are talking about average atomic mass, unit kita is always AMU. So letak sebab just to make sure kita tak lupa nak tulis unit dekat final answer. Okay, and then ni tambah tambah, okay, and our second isotope is lithium 7. Lithium 7 dia punya percentage abundance is 92.58%. Darab dengan isotopic mass which is 7.016 AMU, kita bahagi 100. Kenapa bahagi 100? Sebab ini semuanya dalam bentuk percentage. Tak nak bagi 100 boleh, tak nak bagi 100, apa kita boleh buat adalah 7.42 tu kita bahagi siap-siap 100 and kita masukkan nilai yang lepas kita dah bahagi 100. Is that clear? Boleh faham so either way boleh. Yes. Yes,
Saya
for
ada
you.
soalan. Percentage tu memang fix ke kena cari sendiri?
Given.
Given, okay.
Yes.
Fix lah.
Yes. Dia memang akan diberikan lah. Ataupun mungkin soalan suruh cari. Nanti ada tunjuk satu contoh yang mana you need to find percentage abundance. Okay. Alright. So jawapan dia kita dapatlah 6.941 AMU, and if you refer to your predictable sekarang, kalau tengok kepada mass number of lithium, memang nilai dia adalah 6.941 AMU. So now you should understand that all the mass number yang kat dalam predictable tu kan, nombor yang lebih besar tu is actually representing average atomic mass kalau kita consider all the isotopes. Okay. So maknanya kat sini kalau soalan tu berkaitan dengan isotop, mesti yang kita cari tu adalah average atomic mass. Is that clear?
Yes, madam.
Okay. So let's try this. Sekejap Kita cari sekejap. Di sini. Oh, sekejap. Lebih kurang macam ni lah kalau you dapat e-book nanti dia kalau you guna apps dia. Okay, sekejap dia lambat. Dia memang lambat sikit, dia loading sikit. So apa yang ada dekat madam punya screen sekarang is actually apa yang kita buat tadi lah. You have neon 20, you have neon 21, you have neon 22, and given that dia punya isotopic mass, maksudnya mass untuk individual isotopes adalah, nampak dia punya decimal number 19.99244, panjang kan? But if you look at the solution given at the end, dia memang ambil semua decimal numbers. Okay, 19.99244 AMU darab dengan, yang tu dia dah bagi siap-siap because percentage abundance is 90.48 bahagi dengan 100. So maknanya you darab dengan 0.9048, you dapat 18.0892 AMU. Masukkan juga semua in your calculation. Maksudnya kalau you guna calculator, ambil semua nilai dia. Okay, take all the values. You akan round off cuma dekat final answer sahaja nanti. Okay. So sebenarnya to round off final answer, dia ada rules dia. Rules sama ada you have to round off your answer to a correct significant figures. Tapi dalam chemistry ni, we not really emphasize on the correct significant figures unless stated dalam soalan. Maksudnya dalam soalan dia kata, please leave your final answer to 3 significant figures, then you need to consider 3 significant figures. Kalau dalam soalan tak bagi tahu, kalau boleh dikatakan untuk average atomic mass ni you follow je dalam predictable, sebab predictable kan diberikan dalam exam. Okay, so you tengok sahaja, oh okay, kalau average atomic mass 2 decimal places, that's why final answer dia adalah 20.18. Tak moving lagi. Apa ni? Sekejap. Apa? Hang pula. I close the apps first. Okay, so let's try this. Okay, cuba korang kira ni yang 2.50, 2.50. Chlorine, dia tak boleh enlarge, tak boleh nak zoom. Boleh baca kan? Chlorine has 2 naturally occurring isotope. You all boleh baca ke?
Boleh.
Okay. .72 AMU. Okay. So maybe you can double check siapa yang tak dapat jawapan, double check kat mana jawapan dia. Because by right maknanya dalam kes ni 68.9256 AMU darab dengan 60.11 plus with 70.9247 AMU times with 39.89%. Okay. Kesalahan dia mungkin dekat masa you tambah tu lah. Okay, tambah. So the final answer, I really hope that to be on the safe side, sebab selalunya kalau ada certain question tu kita memang insist on the unit. So untuk yang average atomic mass ni, madam really advise you to write the unit. AMU tu kena ada dekat final answer. Jot down sikit lah. Unit dia biasanya is insisted. Okay, so untuk yang ni maybe you can screenshot ke ataupun mungkin tadi dah sempat salin soalan dia 2.50 ni. Nanti later siapa yang dah ada jawapan je you boleh share dekat WhatsApp group Okay. So got the question? Nampak Screenshot boleh? Okay. Alright. Okay, so I think I'm going to move to the next slide. Do you have any questions on this?
No, madam.
No, madam.
Okay. So insyaAllah, I have around 2 more slides that I want to cover with you today. Lepas tu kita akan stop live class. You can continue with practice question yang madam akan share nantilah. Okay, sebab kelas ni pun dah petang-petang you all dah sangat pack dah pagi kan. Okay, nanti besok kita sambung lagi. Alright, so when you look at this slide, okay, this on this slide we are still talking about mass or weight. Okay, mungkin dalam physics mass and weight ni different, right? Tapi dalam chemistry ni kita anggap dia boleh digunakan dua-dua in any condition. You boleh guna mass, you boleh guna weight. So another terms that we can always use to represent mass or weight is relative atomic mass, yang you all guna same atom relative, same molecule relative tu. Okay, benda yang sama. So relative atomic mass, when we have the word relative here, it means that we compare. Okay, kita compare. Compare dengan apa? Compare dengan our standard again. Okay, so contohnya kalau madam tanya, by right semua dah boleh jawab. If I ask you what is the average atomic mass of lithium, then jawapan dia adalah 6.941 AMU, right? Okay, and then now if I ask you what is the relative atomic mass of lithium, what is relative atomic mass of lithium, then by right you will automatically referring to the same number sebenarnya, nombor yang sama. Mesti you akan refer kepada mass number of lithium, which is 6.941. Tetapi bila kita cerita pasal relative atomic mass, kalau average atomic mass unit dia adalah AMU, tapi kalau relative atomic mass, there will be no unit. Kenapa tak ada unit untuk relative atomic mass? You just look at the formula yang dibagi kat sini. Formula of relative atomic mass is average atomic mass. Okay, average atomic mass untuk lithium tadi kita tahu 6.941 AMU, right? Okay, and then because the word relative maksudnya kita compare dengan standard, so that's why kita bahagi dengan 1/12 darab dengan mass of one carbon 12 atom, in which the mass is always 12 AMU. Okay, ini darab ini, so sebenarnya 6.941 AMU bahagi dengan 1 AMU, so the unit can be cancelled out, and kita tahu the relative atomic mass of lithium is 6.941. So nombor yang sama pun sebenarnya. Okay, so mass number tu yang kita tengok dalam periodic table tu, pertama we can use to identify how many proton, how many neutron and also electron. Okay, kedua we can use it as average atomic mass, yang mana bila average atomic mass, daripada situ kita boleh tahu how many isotopes, what is the percentage abundance of the isotopes, kan, daripada nombor yang sama. And at the same time kita tahu juga mass number is also relative atomic mass. Okay, so tengoklah, you kena tahu, maknanya kita kena guna terms dengan betul. Kalau kita sebut relative atomic mass, dia tak ada unit. Kalau average atomic mass, unit dia adalah AMU. Tetapi nombor yang sama. Is that clear?
Okay, madam.
Yes,
madam.
So last but not least, in terms of mass, ada satu lagi. We call it as yang you all sebut tadi lah, molar mass. Okay, so molar mass. Kalau madam tanya, what is the molar mass of lithium? Jawapan dia apa? What's the answer? What is the molar mass of lithium? Okay, bila tengok kat periodic table, you akan refer kepada nombor yang mana? Nombor besar ke nombor kecil?
So,
nombor besar je
besar
si
kan?
molar.
Yes, so nilai dia berapa? What's the value?
3.
Tu nombor kecil tu.
6 point...
Betul lah tu, Adam teruskan.
6.941.
Yes, okay. Nombor yang sama. Sama je macam tadi. Average atomic mass sama je dengan relative atomic mass. Molar mass dia pun juga 6.941. It's all about the mass number. Cumanya bila kita cerita pasal molar mass, we are actually talking about mass in gram of 1 mole of substance. Maksudnya kalau molar mass, unit dia adalah gram per mole. 6.941 gram for every 1 mole of lithium. Okay, boleh faham? So this concept sebenarnya kita akan discuss lebih detail lagi under mole concept. Tapi just to describe to you apa yang kita ada dekat slide ni. So you can see that for an atoms, molecules and ion, again because of they are extremely small, then kita tak boleh guna dozen. Kalau kita cerita pasal dozen senang je, 1 dozen of balls. Then kita tahu dia ada 12 biji, right? Okay, half dozen, then it is equals to berapa?
6.
6. Senang kan? Very simple. And if I ask you in one car, there are how many tires?
4.
4.
Oh.
You all boleh jawab dengan cepat sebab kita tahu benda tu kita boleh tengok. Okay, nampak? Yes, there are 4 tires. Okay, and then baju Melayu ada berapa poket? Then mungkin boleh jawab. Generally there are 2 pockets, for example, kan? Very easy. Tapi bila kita cerita pasal atom, then kita kena ada satu unit yang khas yang mana kita panggil dia sebagai mole. Okay, so 1 mole of atom. Mole ni boleh eja M-O-L-E boleh, itu nama penuh dia mole, ataupun you can spell it as mole. Itu short form dia sebenarnya. Okay, short form dia. 1 mole of atoms, 1 mole of molecules, 1 mole of ions. Okay, tak kira lah atoms ke, molecules ke, ions ke, sodium atom ke, CO2 molecules ke, ataupun NO3 minus ions ke, kalau dia ada 1 mole, then dia akan ada ni. Apa ni? What is this?
Avogadro number.
Avogadro's number. Yes, that's correct. It is an Avogadro's number. So tak kira lah dia macam 1 dozen, dia memang fix lah. 1 dozen mesti 12. So kalau 1 mole, dia mesti 6.02 times 10 to the power of 23 entities. Tak kira lah atoms ke, molecules ke, ions. So dalam kes ni contohnya kalau kita ada 1 mole lithium, 1 mole of lithium, then automatically kita tahu kita ada 6.02 times 10 to the power of 23 atoms lithium. Kan? Ada sebanyak tu bilangan biji lithium atoms tu kita ada Avogadro's number. So you just imagine that kita ambil 1 mole of lithium ni, kita pergi timbang. Pergi ke weighing scale and then kita timbang. Kalau lah as simple as that lah, tapi unfortunately kita tak boleh buat begitu. Okay, so kita ambil dan timbang, berat dia adalah bersamaan dengan berat 1 mole tadi bersamaan dengan
6.02.
6.02.
6.941.
Itu adalah bilangan biji dia. 1 dozen ada 12 biji bola. So 1 mole ada 6.02 dan 10.23. Yes.
941.
6.9.
Yes, that's correct. Kalau kita ambil timbang 1 mole lithium atom tadi, berat dia adalah 6.941 gram. So itu kita panggil molar
Molar mass.
Molar mass. Yes. Itu je yang Meda nak sampaikan. Sebenarnya the mass number can be average atomic mass, can be relative atomic mass, and also can be molar mass with a different unit. Okay. Alright, so I think that's all. Itu sahaja yang Meda nak cover hari ni. Okay, so you can do more practice by using tadi 2.50 dan juga ada PDF file yang Meda akan share dekat dalam WhatsApp group. Okay, so do you have any questions that you want to ask before we end our live class? Yang ni kita akan cover besok. Okay,
medium.
if no, then let's close our class with tasbih kafarah and surah al-Asr.